Year 2 Pure, and this is a new chapter, and we're going to be looking at Chapter 5, Radians. So let's get started with this new word that we've not heard before, define what it means, and see how we use it. So in the first lesson today, part 5.1 is where we're going to actually say what a radian is. These are really important radians. It starts off as something that seems so basic, so simple, but it opens up so many possibilities that you're going to need in your rest of your A level, and it will define a large part of the rest of your A level. But further on from that, wherever you go with maths, you're always going to be faced with using radians. So before we go any further, let's define them in opposite to something else. And let's say, first of all, let's talk about degrees. So degrees are a way of measuring angles. And you will have been aware of this way of measuring angles for many, many years now, perhaps since primary school. And these degrees are, a degree is defined as 1/360th of a circle. So if you cut a circle up into 360 little sectors, each sector is going to be 1 degree. The angle which we turn through for that sector is going to be 1 degree. Why? Why 1/360th? Why did we decide 360? What was that reason? Well, we can go further back in history and look at this, and it's not immediately obvious. So it seems to go back as far as ancient Babylonia. The Egyptians seem to have a degree there. Some people say that it's because there's 365 days in a year, and 360 and 365 are quite close. I don't believe that. I don't see why you would choose. Why not just choose 365? These people really depended on the cycles of years. So they'd have known that it was 365 days in a year. They'd have known this. So I don't think they kind of made a mistake and kind of went, oh, 360 days in a year. All right, we'll go with that. I don't think at any point they sort of thought that. I think they've always known that there were 365 days in a year. So that doesn't follow. Another reason why we have 360 is that or it could be because 360 divides easily. There's so many different factors of 360. 360 is 6 lots of 60, and 60's got lots of factors. So there's a nice roundness to 360. You can split a circle up in many different ways into halves, quarters, eighths, thirds, sixths, twelfths, and you will always get a whole number, but it divides into. So maybe the reason why we have 360 degrees in a circle is because that's 360, and therefore your circle divides up easily. Perhaps. So that's a degree, but it's not a mathematical enough way of defining it. We need another way of measuring angles, a more mathematical way. And the way that we're going to do this is with radians. Now, the way that we define 1 radian is if you've got a circle and you take its radius and you go out to the circumference, and then you draw its radius across its circumference. That angle that you have turned through when you go through this is 1 radian. So if you've got a radius here then the radius along the circumference of a circle is 1 radian. So that's how we define a radian. A much, much more mathematical way. It's sort of more logical to do this than just going, well, you know what, we'll break up the circle into an arbitrary nice number to divide and we'll go with that. No, radians, much more logical, nicer way of doing things. And what we're going to notice is that we'll have a couple of applications of this, but and you'll kind of go, yeah, all right, that's kind of neat. That does make things a little bit easier. And then we're going to like really drop the big bombshell on you. Radians allow us to do calculus. They allow us to do differentiation and integration with trig functions. And that's what we've got coming up in a later video and in a later part of this course. But for now, let's just say radians really do open up whole new worlds to us. So yeah, that's what a radian is. Now, if 1 radian is defined as the radius across a circle around, if 1 radian is the radius around the circumference of a circle, the angle that it turns through there, then if we go through the whole, around the whole circumference, if you go back to your formula for the circumference of a circle, you'll remember that the circumference of a circle is 2 pi r. So we can fit in 2 pi lots of these radians into 1 circle. So we can say that the circle has 2 pi radians in it. Now, this allows us to convert between radians and degrees. We know that there are 360 degrees in a circle, and there are 2 pi radians in a circle. So there are pi radians in 180 degrees. Or you can even look at it as 1 radian, the distance, remember, for radius around the circumference. That 1 radian, or the angle that it turns through, sorry, 1 radian is equivalent to 180 over pi. And we can use this as a conversion, like we convert between miles and kilometers. When we have so many miles, what we do is, well, we know that 1 mile is 8 over 5 kilometers. So we take the number of miles and we multiply by 8 over 5. So here, what we do is if we want to convert between radians and degrees, we take the number of radians and multiply by 180 over pi. So let's have a go at a couple of examples where we convert between radians and degrees. And that will be the rest of this video, is looking at how we turn radians into degrees. And then later on, we'll look at turning degrees back into radians. So let's have a look at our first example. So 7 pi over 8 radians, how many degrees is that? Well, on the last slide, we saw that 1 radian is 180 over pi. So what we do is we take 7 pi, that's just over 8, and we times that by 180 over pi. And the pi's, you'll see that cancel. So you do 7 eighths of 180. And if you work that out, it's 157.5 degrees. So you take however many radians you've got, and you multiply it by the 180 over pi, the number of degrees in 1 radian. So we do that. So let's have a look at an example where I want you to have a go. So as I've said before, make your notes now, pause, make your notes, and then have a look at this example and pause again. Okay, let's have a go at this one here. So this time we're going to do 4 pi over 15, and we're going to multiply by the conversion factor, which is 180 over pi. And if you whack that into your calculator or work it out by hand if you want to, you get 48 degrees. Easy peasy. Now, what we have to do here is, or what we have done here is we've gone from radians to degrees. What happens when we go from degrees to radians? Well, what we're going to do this time is we're going to divide by 180 over pi. Or another way to look at it would be to multiply by the reciprocal of 180 over pi. So what we're going to do on this example is we're going to take 150, and this time we're going to multiply by pi over 180. Just in the same way, if you're going from kilometers to miles, you multiply by 5 over 8, instead of where you're going from miles to kilometers, where you multiply by 8 over 5. So let's get on it. Let's do 150 multiplied by pi over 180, because it's the reciprocal of 180 over pi. And you've got 5 pi over 6. You might think this is a bit weird. That's radians, by the way. You might think it's a bit weird that we've got these pi's involved, but we get used to it. It's something that you'll see a lot. When we're talking about radians, you'll see pi given there. Pi is just a number. 5 pi over 6, you could work out the decimal expansion of that. It wouldn't be exact, so don't do it when you've got an exam question, unless they ask for decimal expansion. But don't do it in the normal event. But that is just a number. 5 pi over 6 is just a number. That's just something that is a certain amount. It's not anything to be afraid of. Right. What I want you to do now is I'd like you guys to have a go at an example. So could you have a go at converting 110 into degrees, please? I mean, into radians. Off we go. Okay, so this time we're going to do 110. We're going to times it by pi over 180, which is just going to be 11 pi over 18. And there you go. We have gone from degrees into radians. Previously, before that, we went from radians to degrees. Prior to that, we saw what a degree was, and we saw what a radian is. There is another angle measure that I know out there. It's like grads or gradients or something. Apparently, there's 100 gradients in, or grads in, a right angle. I think it might have had something to do with Napoleon, but I'm not exactly sure. And in all my experience of using math, I've never really had to use it. So you're going to be using radians. You're going to use them more and more throughout year 13. You will use degrees every now and again, but we need to now practice just getting used to radians, converting them between degrees, and from degrees to radians. You need to practice this before we get on and actually start using them for other purposes. But For now, could you have a go at exercise 5A for me, please? Thank you very much.